The million-dollar question. How did Earth end up with hundreds and thousands of different species? How did we end up with so much biodiversity on this planet? Today, we're talking about speciation, the process that makes all of that possible. So first off, what is speciation? Speciation happens when one original population splits into two or more new species. Basically, one species turns into multiple species over time. The key idea is this. The new groups can no longer successfully reproduce with each other. But what stops them from breeding? Well, a lot of things can change over time. Things like their chromosomes might rearrange. Sperm from one group might no longer be able to fertilize eggs from the other. Their hormones might shift so that they breed at different times. Or their mating behaviors might change so dramatically that they simply don't recognize each other as potential mates anymore. Once they can't produce healthy, fertile offspring together, we consider them separate species. There are two main ways that this can happen: allopatric speciation and sympatric speciation. Let's start with allopatric speciation. The prefix allo means separate. This happens when a population gets physically divided. Imagine a river changing course and splitting a group into two. Now the two sides can't mate with each other. Over many generations, mutations happen. Natural selection pushes each group to adapt to their slightly different environments. Eventually, they become so different that even if the river disappears, they can't successfully reproduce anymore. That is allopatric speciation. Now let's look at sympatric speciation. The prefix sym means together. This happens without a physical barrier. The population is still living in the same place, but something changes within the group. Often, it's a mutation that makes certain individuals unable to reproduce with those who don't have that mutation. This is especially common in plants, where chromosome duplications can instantly create reproductive isolation. Even though they live side by side, they become separate species. So now let's talk about one of the fastest ways new species can form: adaptive radiation. Adaptive radiation is when one species rapidly splits into many new species, each adapted to a different way of life. To understand that, we need one more definition: ecological niche. An ecological niche is basically a species' job in its environment, what it eats, where it lives, and how it survives. It includes the resources it uses and the environmental conditions that it needs. Adaptive radiation often happens after a big environmental change, like a mass die-off. If many species disappear, the survivors suddenly have access to new food sources and new habitats. Their descendants may specialize in different niches, and over time, they split into separate species. The classic example of this is Darwin's finches from the Galapagos Islands. An ancestral finch population arrived in the Galapagos Islands and found all kinds of food: big seeds, small seeds, insects, and cactus. Some birds had traits that made them better at cracking big seeds. Others were better at catching insects. Natural selection favored those useful traits. As the finches spread to different islands and focused on different food sources, they mostly mated with birds eating the same foods and living in the same areas. Over time, those differences added up and they became separate species. That's adaptive radiation in action. So, to sum everything up, a lot of the biodiversity that we see on Earth today is the result of speciation, where one species splits into two or more new species.